Morning, you're on to Mamu with Jarvis. This is our grade 10 experience. And today we're going to consider the matter of algebra. And our first topic under this will be indices. It's the practice over the years to take indices and logarithm together. But I'm going to take indices alone and take logarithm and standard form using my grade 8 model to handle what we're going to do in logarithm as a follow-up from what you have studied in grade 8. But for today, I'll restrict myself to just indices. I've done loads of videos on indices. So this class will be more like a very fast class. At the end of this class, when I've uploaded the video, I'm going to attach links that will help take you to those videos so you can watch before going into this. This will be more of an engagement class. But just to keep things straight, I will start off by trying to introduce the matter of indices. So what is indices? Or more importantly, what is an index? Index, singular, indices, plural. So an index tells us how many times a base or a number is being multiplied. English, so let's write on the board and see how that works. If I write 4, for instance, 4 is a number, I can write 4 as what? 2 times 2. How many times have I multiplied 2? Is 2 times. So technically in maths, we write an index as what? A superscript. So this one here is the index telling us how many times this base is multiplied. So I'll call this base, I'll call this index. So the number of times a base or a number is being multiplied gives us an idea of what the index is. So I can take another number. Let's say I take 9. And 9 will be equal to what? 3 times 3. And what is 3 times 3? It will mean that 3 is multiplied 2 times. You can see it. I'm seeing 3 here, I'm seeing 3 here. That becomes 3 multiplied twice. So an index gives us an idea or the idea of how many times a number, or technically a term, is being multiplied. Because if I have a times a, this will give me a squared. So we're not just restricting ourselves to only arithmetic. We are also going to delve into the realms of algebra. That's why we're treating indices under algebra, so that we have a broader spectrum of what we are covering. So a times a will be what? A squared, meaning this a is multiplied once, this a is multiplied once, and when I multiply them, I'm going to have a multiplied twice. So a times a will give me a squared. So this, by way of introduction, is what the matter of indices is all about. So what happens at the realm of what is called the index is what is of interest to us as mathematicians while considering this topic. All right, so to keep things nice and smooth, our textbook of reference for this particular course will be our New General Mathematics for Senior Secondary School, SS1, which is technically called grade 10, and we will be flowing from page 16. Exercise 1A in that page is a callback to your grade 8 experience. In your grade 8, you have the topic there, indices, and here we want to try to, from that topic, pull out what you should know in preparation for this particular topic. Essentially, your grade 10 experience of indices will focus on your understanding of laws and how these laws can help you solve problems quickly. So let's go to exercise 1A. Exercise 1A. And we'll try to solve some of the questions, and then you see how these things work, because these will form the basis for us generating the laws we're going to be using much later. All right, so we go to number 1. It says 10 raised to the power of 5 times 10 raised to the power of 4. Or you can call it 10 index 5 times 10 index 4. Now, in your grade 8, you were taught a technique called expansion. This will mean that 10 is multiplied what? 5 times. Times. This will mean that 10 is multiplied what? 4 times. I only have to break this into 2 lines because this one line will not have taken it. So hence I'm using this approach. Now look at it. 1, 2, 3, 4, 5. 1, 2, 3, 4. So if we say 10 index 5 times 10 index 4, what would the answer be? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that will give me what? 10 to the power of 9. How did we get that? You discover that 5 plus 4 gave me 9. So invariably, what I had done was to say 10 to the power of 5 plus what? 4. So what the conclusion we can quickly draw from there is that when I multiply numbers, essentially I am adding their index or their indices. And that gives me 10 to the power of 9. It is important to note at this point that when we deal with indices, the base must be the same. The base must be the same. Now look at this. If I have a to the power of 2 times b to the power of 3, there's no way I can do anything here because a and b are not the same numbers or the same base. So there's nothing I can do here. So my answer will just be what? A squared b cubed. So you see that the first thing you must take note of in solving problems is that the base must be the same. All right, so that's for number 1. We go to number 2. Now, number 2 says a to the power of 3 times a to the power of 9. First check. Are the base the same? Yes, the base is the same. Are we multiplying? Yes, we are multiplying. So what should happen to their indices? You add them. So this will simply be what? A to the power of 3 plus 9. And that will give me a to the power of what? 12. And that solves that. So we go to number 3. In question 3, we're told that 5y to the power of 4 times 5y times 4y to the power of 4. Hope I got that right. Yes. How do we solve this? Now, you will notice that you have number and a letter. You have a number and what? A letter. Now, recall what we had done earlier. We said that in multiplying terms, we take into consideration sign, numbers, and letter. You see that they're all connected. Sign, number, letter. That's how we expect your answer to be presented. So in solving this, what do? I multiply the numbers first. 5 times 4. That will give me what? 20. I consider the letters. Now, there's a new idea. You know, when I was solving here, I said a times a is equal to a raised to the power of 2. Why? If this a is multiplied twice. If I have a alone, it means it's to the power of 1. If I have a alone, it means to the power of 1. So this would have been what? A to the power of 1 plus 1. And that's giving me a to the power of 2. So anytime you see a letter alone, it means that that number or letter, depending on what is given to you, is to the power of what? 1. Right? So that will be 20y to the power of 1 plus 4. And that will give us what? 20y to the power of what? 5. Now recall that at grade 10, I'm not using the expansion technique. I'm introducing you to the concept of laws gradually. So there are 2 ways you solve. You can use by law or by expansion, but we're focusing on the laws because at grade 10, our focus is to ensure that you're able to solve these questions as quickly as possible. All right, so let's catch a little breath. All right, so we will now try to look at next set of questions. We've tried to handle when we are multiplying. So what happens when we are dividing? Still on that same exercise 1E. We look at, now this is a callback to our grade 8 experience. I'll go to question 5. With what I've done, you should be able to answer and do question 4. M to the power of 8 divided by M to the power of 5. From our grade 8, we know that when you say divided, it means that you're writing as the fraction of numerator over denominator. I always advise my students to write in this manner. It gives clarity to your work. Now, this will give you what? M in 8 places: 2, 3, 4, 5, 6, 7. Maybe I should bring this one this way. 8. I think that divided by M to the power of 5. So M in 5 places. M multiplied 5 times. 2, 3, 4, and 5. Now, remember that in relating fractions, we relate fractions with respect to numerator over the denominator. So that means we can cancel out 1, 2, 3, 4, and 5. So after canceling out, what we are left with is what? 3. 1, 2, 3. So that means that this will be equal to what? 3. Now, what's the implication of this? It means that when I divide terms or numbers that are the same, what I'm doing to their indices is that what? I am actually performing what? Subtraction. So if I'm to rewrite this will be what? M to the power of 8 divided by M to the power of 5. I always tell my students, try to write in this manner. Will essentially be M to the power of 8 minus 5. And since we have done subtraction, we know how to handle subtraction. This will simply be what? M to the power of what? 3. And that takes care of that answer. If you look at question 7, I'm picking questions now. If you look at question 7, it says 24 x to the power of 6 divided by what? Divided by 8 x to the power of what? 4. 24x to the power of 6 divided by 8x to the power of 4. Now, from your knowledge of division, because this is a class where I'm trying to slow your imagination down into, this is technically what? Remember that I've done something before that says sign, number, and what? Letters. So here, I will split the numbers out. That's what I'm going to do. This one, I treat numbers to number times what? Letters to letters. So this will be equal to what? This divided by this will give me what? 3. Now, I don't need to be canceling out. I will just look at their indices. Look at it. 6 minus what? 4. Because we said when we are dividing, what are we essentially doing? We are subtracting. The operation that happens at the level of your indices will be what? Or at your index will be what? Subtraction. So this will now be what? X to the power of 2. How did I get to 6 minus 4? Please take note of something. In modern mathematics, we don't write too much. You don't write too much, but just ensure that what you're giving is logical enough for the examiner to flow, especially if you're going to be handling more of the Cambridge experience, checkpoint Cambridge experience. They are more tactical in their approach, so you really need to be to prove to the examiner that you know what you are doing. All right, so that takes care of that. That's for question 7. And we go to question 8 because I'm just trying to hit on the ones we had done. Now in question 8, what happens when you have 2 raised to the power of 0? 2 raised to the power of 0. Anything raised to the power of 0 is equal to 1, but there's an exception to that. Okay, that's for that. But I'm going to add something to that. Now, if I have a to the power of 0 is equal to 1, anything raised to the power of 0 is equal to 1. But where a is not equal to 0, if a is equal to 0, something else will happen. So take note of that. A raised to the power of 0 is equal to 1, provided a is not 0. Take note of that. So that's the only observation I want you to have in that one. So this is more like a callback from what we had done previously. And I'll take one more question that is testing your knowledge of, let's go to question 11. In question 11, the idea tested there is a concept of reciprocal. For instance, if I have 4 raised to the power of -3, the negative there is reciprocal. The negative there is what? Reciprocal. So I can write this to be what? 1 over 4 raised to the power of 3. Now, maybe that is too fast for some of us to perceive. I hope there's something else we'll treat, but for now, take it this way. But I will start taking the laws one after the other. I will break this concept down. There's a way I will show you this concept and it becomes something that you can really flow with. All right, so that settles that. And I'm going to stop at that one because the other questions there essentially involves your ability to work with the laws. But these are about the basic laws you would have been taught in your grade 8. And we're going to use this as a basis to attend to what our grade 10 work should look like. All right, it's our practice in giving the laws of indices to use the letter X, small letter X, that's this. So my description will be in terms of X, the base number will be in terms of X, and my indices will be in terms of A, B, maybe MM, as the case may be. Now, we said that the essence of studying indices at grade 10 is to increase your speed of work. So to do that, we study the laws. There are laws you need to know that will help you do your work faster. So I'm going to give you the laws. It may not be the same way you have seen them in books, but the ideas will essentially be the same. Now, we have the first law, which is saying that if I multiply a base to the power of A by another base to the power of B, remember that we have said that these laws only work when the bases are the same. So x to the power of A times x to the power of B, this will give me x to the power of A plus B. So when I multiply terms, essentially I am doing what? Adding their index or their indices. All right, so this is the first law that if I have x to the power of A multiplied by x to the power of B, essentially what I'm doing is to do what? Add up their indices. So that's what that will be. Now, law 2 says, remember that we've actually tried these things out. So it's something that we already tried. And if you more, like I promised, I'm going to attach a video. After uploading this, I'm going to attach links for you to watch all that detailed explanations I've done on this topic. Now, if you have x to the power of A divided by x to the power of B, I usually encourage my students to always write it in this manner. Write it as a fraction. This will mean that x will be raised to the power of A minus B. Means subtract them, the first minus the second. Now, number 3, it says x to the power of 0 is equal to 1. Remember that I said that this only occurs where what? X is not equal to 0. And it will interest you to know that this also holds for every law we have under indices. X must not be equal to 0. Now, don't ask me, sir, why? It's not for your consumption now. For those of us who are interested in eating deep things in maths, you can make inquiries and find out why that holds true. Right. Now, the next one we have is the one I call the concept of what? Reciprocal. If I have x to the power of -1, this is called the reciprocal, or what some books will call the negative index. This is just one variant of it, because in books you may not. So I'll call this 4a1. I like to break it down. This will give me 1 over x. Then b will be x raised to the power of -a. If this raised to the power of this could also be x raised to the power of what? A, or raised to the power of -1. This -1 means what? 1 over. This will be what? 1 over x raised to the power of what? A. Now, this is a concept of writing negative index to become positive what index. So this is a negative index, negative index. This is a positive index. So you could be asked to write from negative index to positive index. This is what they did. Now this one is called the law of zero index. So this is zero index. So this concept is called the zero index. If I just write that one here, so I'll just put a hash. I'll call that zero index. I'll put a hash here. I'll call that, okay, let's put that on top so it doesn't confuse us. I'll call this a negative. So that's a negative index, and this is zero index. Now that's for that. Now we'll come to law number 5 that says if I have x to a certain base and it's being multiplied by another base, sorry, x to a certain power being multiplied by another power, what does that mean? Now, this means that x to the power of a is raised to b times. I'm going to explain this much later. This will give me that x to the power of a will multiply b. So this technically what x to the power of what? A, b. Let's project this a little more because this is more like the idea we've not touched on. If I have a to the power of 3 or raised to the power of 2, but our concept of expansion means that this a to the power of 3 has occurred 2 times. So a to the power of 3 will multiply a to the power of 3. This a to the power of 3 has occurred 2 times. A to the power of 3 has occurred 3 times, but a to the power of 3 has occurred what? 2 times. You get it? The a in the bracket occurred 3 times, and everything has occurred twice. Now, this, from your knowledge of what we have done from first law, this will simply be what? A to the power of what? 3 plus what? 3. And I'll be a to the power of what? 6. Don't you see that if I multiply 3 by 2, I'm going to get 6? So we can just say directly that what? A to the power of 3 or raised to the power of 2 will simply be what? A to the power of what? 3 times 2. That will be a to the power of 6. So you see that we had said that the concept of the laws is to make your work to move what? Faster. All right, so that's that for that law. There's also the one we call fractional index. Fractional index. Now there are 2 variants to this. Variant A says if x is raised to the power of 1 over n. We usually use n to depict roots. So this is the concept of roots now. So a fractional index suggests the concept of roots of the number. So roots. So 1 over n will usually mean what? Roots. So that will be what? 1 over n. 1 over n. So 1 over n suggests the fractional concept of fractional index. So this will simply be what? The nth root of x. This will simply be what? The nth root of what? X. Now, I can also have variant 2, which will be what? X raised to the power of what? M over n, which would imply find the nth. Now, you remember your board maths, or some books will say big maths. There are certain things you need to do first. Now, if I have roots, I will deal with the root first and then multiply it by n. Remember, look at what has happened here. If I, okay, let's have a part of the board to explain that idea. Now, just to, you must try to see the connections as we go. If I have a to the power of, or rather x to the power of a, or raised to the power of b, being equal to x raised to the power of ab. Now, let a be equal to m, b be equal to what? 1 over n. You discover that what you're going to have will be what? X raised to the power of what? M, or raised to the power of what? 1 over n. Is that not? What would this one be? This one will simply be what? X raised to the power of what? M times 1 over n. And that will be what? X raised to the power of m over n. So you can, now let's go back. We can write this backwards. And when you write this backwards, you discover that at this point, if I start from here, I'm going to come to this point. Do you understand? We'll come to this point. But in using our concept of big maths, we will need to do the roots first before we do this. So that's what we have done here. So that's why it became what? Find the roots first, and then how many times you have that, how many times are those values going to be what? Multiplied. So that's for I call that law 6. I call that law 6. I gave you 2 variants of that. Although in some books you see it as 6 and then 7, but the ideas are essentially the same. The concepts are essentially the same. So let's take a break to digest what we've done. Okay, so we'll go to exercise 1B of our text, the New General Mathematics. And I will not solve all. I'll just pick a few of the questions, but it is in your own interest to solve everything. Remember, the whole idea is that you apply the laws. How well you're going to apply the laws, or recognize the laws first and apply them, is essential here. So we'll go straight ahead to look at exercise 1B. I'll pick a few of the questions, and I'll do number 1. Number 1 says a to the power of 3 always to the power of 2. We said that this means a to the power of 3 is occurring how many times? 2 times. So this will mean that a to the power of 3, there are 2 ways you can write this. You can solve like this, 3 plus 3, and that will give a to the power of 6. You can also solve like this. Whichever pattern you use, you are very correct. But take note of something. As you begin to advance, we wouldn't expect you to use that. Let's take another example. Let's look at question 2. If you look at b to the power of 2, always to the power of 4. Here, I would insist you do this. Because we said that b occurring twice and then everything occurring 4 times will mean what? 2 times 4. Straight away. And that will be what? b to the power of 8. These are questions that you should solve within 10 seconds. If you're spending 15 seconds on this question, something is fundamentally wrong. It means you didn't get the concept right. So modern math is about time. It's about grasping, having a strong grasp of the concept and able to deliver within record time. You can't spend more than 15 seconds handling this. You can't. Right? So that's for question 2. And that said, I'll go straight ahead to question 8. Now, if you look at question 6 rather, I have f to the power of 0, or is the power of 8. Now, there are 2 ways you can solve this. A student can recognize that f to the power of 0 is equal to 1, or is the power of 8. And that final answer becomes what? 1. Now, this is one question. You know, when we are giving exercises, there are specific questions I look out for. They may look very, what's there? But they are questions that drive your understanding. Now, 1 raised to the power of anything is equal to 1. Take note of this. 1 raised to the power of anything is equal to 1. This is another law that you may need to take note of. If one is, even if this thing is a fraction, it will still be what? 1. Provided that a, so a, 1 raised to the power of a is 1. And then if you do your investigation and you have a contrary opinion to that, you can let us know in the description below. All right, so 1 raised to the power of a is equal to 1. Now we have done that. There's also another way we can solve this. I can also solve this in this manner. I can say f raised to the power of 0 or raised to the power of 8 will simply be what? F to the power of 0 times 8, which will be what? F to the power of what? 0, which essentially will be 1. See that? So there are 2 ways you can solve this. And that's the beautiful thing about this area of maths. There's not one particular way to solve. But as we begin to solve, at some point in time, I will insist you use particular methods because some methods seem to give you the answer faster, and some methods tend to stretch your thinking ability. All right, so that's settled for that. Now, let's go to question 8. Like I said, I'm just doing random solutions. H raised to the power of 4 or raised to the power of -5. It's still the same thing. Here, your knowledge of directed numbers or integers becomes very important. This will simply be what? H to the power of 4 times -5. I'll advise you case -5 so you don't forget. But if you don't case it, that's not the problem. But just ensure that you don't forget that what you've written down is negative. What is negative times positive? It is negative. So H will be equal to -20. I've also done works on arithmetic, talking about behavior of numbers and things like that. You may want to look up my YouTube channel, grade 10, on this matter. You really need to work. You really need to work. Just spend time watching. The way I've done my videos, you can actually just watch without having to do much writing. Right, so that takes care of that question. And I think sometimes they may ask you to write a positive index. Remember we said that this is a negative index and suggest what? Reciprocal. So the final answer, if you decide to go by way of writing a positive index, will now be what? 1 over H raised to the power of 20. This negative means that I am actually a denominator. Let that sink. Anytime you see a negative, it means I'm actually a what? A denominator. We're going to see when we start solving other questions, practical exam questions, that some of these rules can be bent a little, but hence we're just introducing a concept. We want to keep it as simple as possible. All right, so that takes care of question 8. And I think that's about that. So let's look at exercise 1C. We should clean off and go to a fresh page. So in exercise 1C, now the narrative is changing a little. It's a little more complex. I have 3 to the power of n, 3m, n is raised to the power of 4, everything raised to the power of 2. Now, remember that there are 2 ways to solve this. I'm going to use the first method, which is suggestive, bringing you from your grade 8, and then I'm going to use another method, which will suggest what you should be doing now. So this will be what? Raised to the power of 2, meaning that 3m raised to the power of 4 is multiplied 2 times. Is that not? What does that mean? Number to number, 9. Letter to letter, 4 plus what? 4. Number, remember our concept. Number, sign, number, letter. Powerful concept. That's the arrangement. Number will multiply number, letter will multiply letter. Now, if you look at this letter, it's to the power of 4. This letter is to the power of 4. So what it means is that because I'm multiplying, I'll simply do what? Add their indices. So that settles that one. But this is where they expect you to go to. Now, this bracket will suggest that everything in here is to the power of 2. So this would technically would have been equal to 3 multiplied twice and n to the power of 4 multiplied twice. You need to see this. It's important to start seeing it at this level like this. So this will give me 9, and this will give me n to the power of what? 4 times 2, and that'll be 8. And we will drop one step down so that for some of us who may be slow at catching that. So this brings us to another interesting law that you may need to take note of. If I have A, B, all raised to the power of, let's say I have this to X, I have this to Y, and this is raised to the power of Z. What this means is that this will be A to the power of X, Z, and B to the power of what? Y, Z. Take note of that. You may want to put that law somewhere. I would advise you get a separate place at the back of your notes. And because some of these laws are things that extra laws you begin to see as you proceed. They are not like general laws, but you need to remember that these things exist because they help you to solve problems better, right? If we've done that, Now, the next one I'm going to solve will be question 4. The next one I'm going to solve will be question 4, because that's the next different idea. I have 4 v cubed all raised to the power of 2. In this context, watch carefully to note that 2, this means that 4 is multiplied by v occurring 3 times twice. V occurring 3 times, or rather v cubed occurring what? Twice. So what this 2 is not affecting this. So this invariable will what? 4 v raised to the power of 3 times 2. This is not affecting this. Watch that, because that's one quick example, one quick error you may make. The bracket is not affecting this 4. Take note of that. So this will simply be what? 4v to the power of 6. And that settles that. Right. Now we go to question 6. Now question 6 has introduced yet another concept, negative 2b squared all raised to the power of 3. Now, to explain this concept, I will go with my expansion technique. This will be negative 2b squared times negative 2b squared times negative 2b squared. Now, go back to our earlier concept, sign, number, and letter. We multiply the signs first. Negative times negative, positive. Positive times negative means what? Negative. So how many terms? 3 terms. I'm getting a negative. How many terms? 3 terms that are negative produce a negative. 3 terms will mean that I'm dealing with what? Odd number terms. Odd number terms. 1, 2, 3. 3 odd number terms. I want you to note that, because that's the essential idea of this concept. Now, look at numbers. 2 times 2 times 2 will give me what? 8. I'm left with b. This is b to the power of 2 plus 2 plus 2. Remember I said when we multiply terms, we are what? Adding them. So this will give me what? Negative 8b to the power of what? 6. All right, we are done with that. Now let's try another idea. Still on that one, let's now try what the rules expect you to take note of. Now, let's now use another method, or look at that. This will mean that negative, when you see negative, it means negative 1 has occurred 3 times, 2 has occurred 3 times, and b squared has occurred 3 times. Now, notice that this is what? Negative times negative times negative, and I'll give you what? Negative times 8 times b to the power of 6, and I'll give you negative 8b to the power of what? 6. So from here to this point, now what are they expecting you to take note of here? What they are expecting you to take note of? If I have negative 1 all raised to the power of n, this will be equal to 1 if n is even. As long as n is an even number, n is an even number. But this same thing will be equal to negative 1 if n is an odd number. This is another law that you're expected to take note of at this point. So please take note of this. It's another crucial idea that you need to remember at this point, because this idea would help you answer other questions. All right, let me give you some time to breathe. Okay, so that will end the part 1 of this series, and I'm trusting that you have learned a little from your laws of indices drawing from your experience of your grade 8. We're going to continue with this class some other time and with part 2, where we'll try to look at the questions we've handled and then we'll take it up from there. As a quick reminder, I want you to go back and see if you can finish up exercise 1A. That's still our text in general mathematics. Look at exercise 1A, exercise 1B, and exercise 1C. In my next class, I'll pick it up from there and then see how we can now go into what is called empirical equations. So I'll pause for now and I'll trust you go back to do your part. Right, thank you.